Hello, my name is Justin Mattiello, a hopeful freshman here at the University of Connecticut. For this year's reverse engineering project, me and my 3 other fellow classmates chose the DJI Phantom 3 because it supplies a wide range of engineering disciplines.
Hi, my name is Liam Wilson, and I'm really excited to get into this reverse engineering drone project because I've been working with drones since I was a very little kid. I'm excited to get into the different fields of engineering, like chemical engineering, to see how they made this lightweight plastic strong, durable, and economically friendly.
Hi, my name is Ryan Zimmerman. I'm a freshman here at UConn as well as an aspiring engineer. One thing I'm excited about this reverse engineering project is to get into the inner workings of this drone and explain the electric engineering and circuits behind it.
My name is Tomas Rosano and I'm a material science engineer. Therefore, I'll be telling you guys about the materials behind this drone and what makes it so amazing. Without further ado, let's get into the video.
Some of the specs here on the DJI here are the battery weighs about 1.2 kilograms. And as you can see, it slides right in the center here of the drone because that way the center of mass stays perfectly in line. Otherwise, you don't want it being tilted like this or like this. So it has nice little tracks right here that keep the battery from wiggling around, and it plugs in right here. All right, so some more specs of the drone are it has a max ascending speed, so going up of 5 meters per second, and a max descending speed of 3 meters per second. Clearly the going down has less because you want it to be more stable coming down. It also can go any direction in the horizontal plane of 16 meters per second of a max speed. Some extra specifications include it can have a max tilt angle of 35 degrees. Also, it has a flight time of around 25 minutes.
The first step for disassembling is to remove the hexa screws that keep the motor in place.
So right here on the outside, we have the compass, and this serves to tell the user controlling the drone when they can see the controller. It's connected to the phone. It'll tell you if you're going north, south, east, or west. And it's on the outside because of the amount of magnetic interference that would occur if it would be on the inside, because all the motherboard on the inside is doing all the transactions, and all the interference would be occurring on the inside. So we need it on the outside.
Okay, so as you can see, after we removed each of the propellers, inside the motors there's a bunch of copper coils around. And the reason that there are these copper coils is because copper has a high electrical conductivity, and that helps increase the energy field around it.
Now that we've taken off pretty much all the exterior pieces, we're now going to start getting to the inside. That requires taking off these little tiny hex screws right here with a 5/64 Allen wrench, and taking off these motors to take apart the plastic.
For the motor and the motherboard connections, the wires are soldered together. So that means metal to metal. So that's the most efficient electrical transmission. And that goes straight from here to here, and then it goes straight to the battery.
So one thing that was really surprising to us about this drone was that each motor, each brushless motor, has its own circuit board. So these things right here are the speed controller circuit boards. And why this is really good, and a good thing that the makers of this drone did, was if one brushless motor isn't working that well or goes out, it's very easy to replace just this single circuit board and motor rather than having to go through this entire drone. So it's nice that it's kept into one area.
Okay, so now to talk about the torque of the drone. So basically when this thing is in hover mode, when you're not actually like controlling it and you want to keep its altitude, the downwards force of it equals the upwards force, and then that keeps it in place and it knows how fast to spin the propellers. And then each propeller spins in a different direction. For example, 2 on the opposite sides will spin counterclockwise and 2 will spin clockwise. And this is to keep the drone just hovering there, because if they were all spinning one way, then the rotational torque would make it spin that way or that way, however it does it. So since they're both spinning in different directions, it keeps the rotational torque in place.
Okay, so now that we're talking about torque, let's talk about how the drone moves side to side and forward and back. So we obviously know that when the drone tilts at an angle, at any angle like this, you have to split the upwards force into its horizontal and vertical components. So you've got a force like this and a force like this. And these unbalanced forces allow the drone to move in that direction. We'll show you the exact calculations and how the drone can move fastest at what angle in a second, but this is just a general overview. So as you can see, we calculated the total mass of the drone here with the drone battery plus the drone mass to get 1,392 grams. We then calculated the downwards force of mass times gravity to get 13.642. And so we know that the force upwards must equal the force downwards to keep the drone stable. So we know that the propellers must be rotating, as we said, counterclockwise and clockwise, and the force up must be 13.642.
Okay, so one thing that we thought was a design flaw was that there were so many connections to the motor port that could easily be unplugged. Like for example, I could easily just go and with very little force easily just unplug that. And if one of those were to come out during flight, it would actually result in the drone crashing or making it very difficult to fly. So one thing that we changed in the future of the drone is that we would have all of these connections be soldered to the main motor port, so that it would be very hard to come off during flight.
Okay, one thing we could do to improve the marketing and sales of the drone is to change from screws like these, that rust, as you can see, to stainless steel screws. Now, one advantage of stainless steel screws is you can market the drone as water resistant and you can fly in the clouds. This is very good because a lot of people like good cinematography at high levels, which there's oftentimes water that can get inside the drone. So using stainless steel screws would allow it to not rust and therefore making the drone a lot better, and you can sell it at water resistant.
With regard to the longevity of the drone, we feel that if you take the right precautions and safety and take care of it, it will last you a long time. As far as safety features, some stuff that we think can be added to the drone to make it more safe is to add guardrails around the circumference of the blade, so it will help not get your fingers chopped off, or if you're going into objects such as wall, it will bounce off and not get caught up as easily. Another safety feature that can be added to this drone to make it more safe is to add sensors around the outside of the drone to sense when you're nearing an object, wall, or person. This would prevent crashes significantly. However, adding those would also raise the cost of the drone.
Carbon fiber consists of carbon triple bonded to nitrogen. This yields twice the stiffness of steel, yet only half the weight of aluminum. The stiffness to weight ratio is 10 times that of steel or aluminum, and this is why the body of the drone is not made out of carbon fiber, because it is not moldable. It's too stiff to bend. So this is why the propellers is perfect for it, because if you have an extreme downward force or an extreme upward force, it won't snap. It'll just keep spinning. The trade-off to all these benefits, though, is that carbon fiber is typically more expensive than the counter parts for the material. But in this case, the minimal amount of carbon fiber within this drone doesn't affect the cost of the drone severely.
I wanna be